All right, this is Unit 3, inverses. This is day 6, square root equation. So we're going back to roots, but this time we'll see equations where we're going to solve for the variable. Step 1 says to always isolate the radical on one side. Then you're going to raise each side of the equation to the power of the index of the root. What we'll be seeing today is square roots for the most part, and you're going to just raise both sides by the power of 2 to cancel that out. Then we'll solve the resulting equation. So here on this one, to isolate the root, we'll first have to add 1 on both sides. So it's the square root of y minus 2 equals 6. Now, to undo the square, we would actually, to undo the square root, we would square both sides. All right, so now I have the square root and the square cancel on the left, so I'm left with y minus 2 equals, on the right, 6 squared is 36. I will add 2. And I'll get y equals 38. What you always want to do here is you actually always want to check your answer in the original problem. So if I plug in the 38 for y, and I simplify that down, that would be root of 36 minus 1 after I subtract the 2. 6 minus 1, that is 5, and that is checking out. So y equals 38 is my final answer. Always want to check your answers on these root problems every single time, whether you're using your calculator or actually writing it out by hand. So you'll see a similar situation here on example 2. Again, you always want to isolate your root first. So in this case, we will add 2 to both sides to do that. So the square root of x minus 3 equals 8. And here, once it's been isolated, that's where you can square both sides. And we'll get x minus 3 on the left equals 64. Add 3 on both sides, and we get 67. And if you do plug that back into the original equation, it does check out in this situation. We'll see a time later where it might not. All right, here's a bit of a trippy situation. What if you have 2 roots? In this case, you can't isolate both roots at the same time. So what you got to do is you got to do one and then the other. Right now I do have the x minus 12 isolated, the root of it. So I'm going to go ahead and square both sides as is. That's going to be a little strange here. On the left, it's pretty easy that you get x minus 12. But on the right hand side, watch out. This will be a perfect square trinomial. A minus b squared is a squared minus 2ab plus b squared. Or you could actually multiply it out by doing 2 minus root x times 2 minus root x. It'll just be getting to that answer I was talking about just a moment ago. So I have x minus 12 equals, this would be 4 minus 4 root x. That's coming from 2 times negative root x would be negative 2 root x. But you also have a negative root x times 2 is another negative 2 root x. That makes the minus 4 root x. And I have a plus root of x squared. Root x times root x. Root of x squared would be x. All right, so what I'm now going to do is I'm actually going to get this root isolated and square yet again. So I'm going to minus this x from both sides. And so that actually canceled. So I'm left with negative 12 equals 4 minus 4 root x. I will subtract 4 from both sides and get negative 16 equals negative 4 root x. And I will divide by negative 4. And I get positive 4 equals the square root of x. Now I'm finally ready to actually square this thing yet again, and x is equal to 16. Before I circle that, I actually want to go back up top and evaluate that on both sides of the equation. So if I have the square root of 16 minus 12, this is the left side. That's the square root of 4, which is 2. Let me try it on the right-hand side. 2, and see if it does equal 2 minus the square root of, now I'll put in 16 for x. Well, that's going to be 2 minus the 4, and that's negative 2. All right, so this clearly did not work. This gave me what's called an extraneous solution. This is called an extraneous solution. You need to know that term. What that means is that by doing the steps algebraically, I get an answer, but it does not work. It's actually kind of like a false solution. The correct answer here is that there is no solution. I only got one answer, and that answer ended up not working. Now, sometimes you might get 2 answers if you get a quadratic along the way, and one of them will work and one of them will not work. But in this case, no solution. A similar situation to the last example, so I would actually start this off by squaring both sides, just to kind of get a feel for it. So I'll have x plus 5 equals, when I square 1 plus root x, again foiling that out, I get 1 plus 2 root x plus x, and that last x was from root of x times the root of x. All right, let's get everything solved for this one. So I'm going to minus this x from both sides. That actually cancels it. I'm going to subtract 1 from both sides, and I get 4 equals to 2 root x. Divide both sides by 2, and I get 2 equal to root x. And when I square both sides, again, I will get x equal to 4. Now, again, we want to check our answer. So this will be the root of 4 plus 5 on the left side, and we'll see if that's the same as 1 plus the root of 4 on the right-hand side. So on the left-hand side, that's the root of 9, which is 3. And we're seeing if that's equal to the left. So does that equal 1 plus 2? Yes, it does. So this answer is good. This is a correct response. X equals 4. All right, going ahead and checking over what these are. This is a 6th root, so it seems intimidating at first, but it's really the same process. Here I would add 4 to both sides to make it 7 times the 6th root of 5m plus 4 equal to 14. Then I would divide both sides by 7. So 6th root of 5m plus 4 is equal to 2. Now, whenever you're dealing with a different power root, you just raise by that power. So this was the 6th root, so I raise to the 6th power on both sides is what I do here. So now I have 5m plus 4 equal to 64. I'll subtract the 4. So 5m is equal to 60. Divide by 5, m is equal to 12. Before you circle that answer, you actually want to go back and check your answer. So what I do is actually in my calculator, I just type in 7 times the 6th root, and that takes a little bit of work to do actually. Alright, 7 times the 6th root of 5 times this answer of 12 instead of m, plus 4, and then I will subtract 4 from it and see if I get 10, and I do. So this is a correct answer. So again, I'm just using the calculator off to the side that you can't see to actually check through that answer and make sure the 12 is good. That wraps it up for today. Just again, please make sure you always check your answers. You want to watch out for extraneous solutions.